everyone. I'm Tengfei from Huawei Cloud, and since I joined Huawei, I have been working on the Web3 technology planning and R&D of the blockchain services. And I'm honored to have this opportunity to share with you guys our thoughts on the direction of Web3 projection. We believe that the Web3 infrastructure is the global computers, as Ethereum becoming a de facto standard. So the most important law in computer is Moore's law. So Moore's law was proposed in 1965 by Gordon Moore, the founder of Intel. Actually, initially, he believed that Moore's law would last for 10 years. However, as the efforts in the industry, the Moore's law have been in fact in about 60 years. As the development of the semiconductor has slowed down, we can state that the Moore's law is failed in the CPU domain, but in another domain, the GPU has benefited from its integration with the artificial intelligence. First, the hardware acceleration for AI, and second, the automation for AI systems, and thirdly, the evolution of AI algorithms and models. All these three aspects contribute to the development of Moore's law in GPU domains. And we found that the chart on the right side compares the stock market performance of Intel and NVIDIA's, which shows a high degree of consistency with the left pictures. This is interesting. So we believe that if the industry's infrastructures can enhance Moore's law development, it will play a crucial role in the prosperity of the entire industry. And from the Ethereum's technology roadmap, we can find that the scaling is a critical task at present. So we see a lot of layer 2 rollup projects are ready to start build with performance improvements and decreasing the construction costs. So that indicates that the Moore's law in Web3 infrastructure is also taking place. And from the right chart, we found that the layer 2 is gradually carrying the users' traffics, and I think the layer 2 liquid rock play a key role in this process, and it is a more future-oriented solutions. And if we compare the global computers with traditional computers, something interesting we will find is the relationship between the layer 2 and layer 1 is similar to the CPU, between the CPU and the GPU. CPU is an eco-friendly processor with relatively slow computing speed, but the GPU provides high performance for AI workloads and rendering nodes. This all together completes the computer world we are using today, right? And the same thing applies to the Web3. The layer 1 serves as a foundation for higher security and trustworthiness, and the layer 2 provided the high performance extension for the layer 1. And actually, the same thing is also happening in Web3 storage and data abilities. The most important technology driving changes, I think, is their knowledge proof. So if we want to maintain the Web3's infrastructure's Moore's law, some efforts need to be made in three directions of decay. First is hardware, the system, and algorithms. The design of their knowledge proof always involves some trade-off between the communication complexity and the verification complexity, proof complexity, and the public common parameter size. Since the blockchain's computation and communication and the storage cost are very high, so the ZK algorithm section on the blockchain tries to sacrifice the proof generation complexity while keeping another three aspects as complexity close to a constant level. So let's take a look at the process of their knowledge proof, which includes service build, completion, and setup and proof generation. And the most time-consuming part is the proof generation. We do some tasks with the common language such as Hello2 and well-persons, and we found that the main reason for time-consuming of the proof generation is two types of operators. NTT and MSM. So let's take a quick look at the feature of these two operators. The first is NTT. NTT actually is a fast Fourier transform on finite field. And on the right side, this picture is a simulation of this argument with 8 inputs. You can find within the same stage, the computation can easily parallelize. But data need to be swept out in and out frequently between the stages. So this type of task requires high memory access. And another important operator is MSM, multi-star multiplications. Actually, it performs the point multiplication between a star and a point on the elliptic curves, and then add them together. It involves a large number of modular multiplication and modular addition operations. So it requires high computational power, and it is parallel-friendly tasks. And if we compare the NVIDIA and MSM, we will find they are different. And as the task complexity increases, the MSM requires high computing power than NTT. And in terms of the memory bandwidth, the NTT requires in outside of its computational power requirements, requiring high memory bandwidth. And this page is important where I will talk about our thought on the hardware accelerations. First, we use the real-time model to model these two tasks and find that for NTT, the acceleration memory bandwidth and the CPU2 accelerate bandwidth, the PCIe bandwidth is the main bottleneck. And for MSM, it's relatively simple, just require more computing powers. And today, if we want to implement the hardware acceleration about their knowledge proof, a common architecture is a CPU with accelerators such as FPGA, GPU, and ASIC. And this is currently main approach in the industries. And today we want to propose another possibility is we combining the CPU and the accelerator into one chip. And in this chip contains many cores. And to support the large, wide instruction size to provide better performance. And additionally, combine the CPU and accelerator together has result in better memory access performance without needing to migrate the memory data from CPU to accelerators. And thirdly, it is built using a CPU processor architecture, so it is programming friendly, and it can adapt to the ever-changing ZK ecosystem. And this is very essential. And this is all our thoughts on the hardware part. And we will conduct some serious tests on our chip and share our testing results next time. And it is well known that there is a limit to the processing capacity of a single chip. So if a single chip can not satisfy a large-scale ZK computation, a natural approach is to use distributed systems. And in distributed system, a multiple accelerator can work together through a high-speed network. And this is the first step. Next step is about a novel bus technology. The main difference between this technology and today's network technology is that it uses memory semantics for communication. By using memory semantic bus, the multiple accelerator can connect to perform virtual shared memory proofs, allowing for tighter and finer-grained communications. And having introduced the system and the hardware part, I will discuss the algorithm briefly. And as the input for proof generation, the circuits offers many optimization opportunities, such as we can using DK-friendly primitives and reducing redundant operations through the lookup tables. And if we tracking the algorithm development in the field over the past decades, the proof improvements of nearly 100 times. So we can make a conclusion that there is a significant room for development in hardware acceleration, system innovation, and algorithm advancements to support the optimization of Web3 infrastructure and ensure the Web3's Moore's law to process. And at last, I want to make a summary of today's talk. Huawei Cloud will complete our VK hardware acceleration based on our chip. And then we will connect the Web3 infrastructures through the network technology and the novel tightly coupled bus technology. And based on these infrastructures, we will provide some cloud services to everyone, such as the cloud instance or the service offerings. And this type of services have many advantages, such as the layer 2 VK project and the other project using VK stack do not have to worry about the performance and the stability issues. I hope our work can contribute to the prosperity of Web3's applications. And I'm excited looking forward to the Web3 mass adoption. And that's my talk. Looking forward to contact and further communication. Thank you.